Good morning, student. In the last classes, we are seeing the chapter differential equation, under which we are solving board examination questions. Okay, students. Now today we will going to start a new chapter, three-dimensional geometry. Okay, students. So we will take some board examination questions one by one and solve it. Okay. Let's see your first question, students. Find the value of lambda so that the lines 1 minus x by 3 is equal to y minus 2 by 2 lambda is equal to z minus 3 by 2 and students, second line x minus 1 by 3 lambda is equal to students y minus 1 by 1 is equal to students 6 minus z by 7. 6 minus z by 7. Okay, students. So students, first of all, students, we write this in the standard form, that is, we write x minus 1 by minus 3 and y minus 2 by 2 lambda and z minus 3 by 2 and then x minus 1 by 3 lambda, y minus 1 by 1 and z minus 6 by minus 7. Okay, students. So students, and our first, this is students 1 minus x by 3, and when we take negative sign outside we get minus 3, and here also this is 7, when we take negative sign outside we get z minus 6 by minus 7. Okay, students, question says that find the value of lambda so that these two lines are perpendicular to each other. So students, you know that if the two lines are perpendicular, then we know that condition a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So we use here, students, and you know our direction ratio are minus 3, 2 lambda 2 and 3 lambda 1 minus 7. Okay, students, so these are the two direction ratios of the equation. Okay, students, so the two lines are perpendicular, so a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So we write minus 3 into 3 lambda plus 2 lambda into 1 plus 2 into minus 7 is equal to 0. Minus 9 lambda plus 2 lambda minus 14 is equal to 0. Minus 7 lambda minus 14 is equal to 0. 7 lambda is equal to 14. So lambda is equal to students minus 2. So this will be the value of lambda. Okay, students, I hope you understand. Because in this question, students, we have to find out the value of lambda, and question says that the given two lines are perpendicular. So we know the condition of perpendicularity, that which is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, where a1 b1 c1 are this and a2 b2 c2 are this. Okay, students, these are the direction ratios. So in this way, after applying this condition, we can get the value of lambda. I hope you understand, students. Now we move to next question. So next question is, students, find the shortest distance between the lines whose vector equations are given. We have to find the shortest distance in the next question, students, and the lines is given in vector form, which is I plus j plus lambda 2i minus j, 2i minus j, and plus k. Okay, students. So R is this, and students, 2i plus j minus k plus mu, and students, 3i minus 5j plus 2k. Okay, students, so two lines are given to us and we have to find the shortest distance between the two vector equations. Okay, students, so we should compare these two equations with R is equal to A plus lambda B. Okay, students, so A1 is I plus j and B1 is, students, 2i minus j plus k, and A2 is 2i plus j minus k, and B2 is 3i minus 5j plus 2k. Okay, students, so our A1, B1 and A2, B2 is given, and students, we know the formula of shortest distance, which is B1 plus B2. Shortest distance is equal to B1 class B2 dot A2 minus A1 by magnitude of B1 class B2. Okay, students, so this is the formula of shortest distance, and students, using this formula we have to find the shortest distance between these two vector equations. So students, first of all we find A2 minus A1. So A2 is 2i minus j plus k minus A1 is, so A2 is 2i plus j and minus k minus A1, which is I plus j. Okay, students, so we write I and plus j, minus j will be 0j, and this is minus k. So A2 minus A1 is this. Now students, we find B1 cross B2, okay, because we have need of B1 cross B2, then we can put this value B1 plus B2 and A2 minus A1 in this formula and get the shortest distance. So student, now B1 cross B2 is, so for find out B1 cross B2, we use the determinant. So our B1 is this 2 minus 1 1 and B2 is 3 minus 5 2. Okay, students, so our I, when we expand these students, we expand and right here our I is minus 2 plus 5 minus j, and this is 4 minus 3 plus k, and this is minus 10 plus 3. Okay, students, we get 3i minus j and minus 7k. So students, B1 cross B2 is this. Now students, we can get the magnitude of B1 cross B2, which is B1 cross B2 is under root, student, this is 3 square whole square minus 1 whole square plus minus 7 whole square. We get, students, 9 plus 1 plus 49, 59. So student, our B1 cross B2 is 50. B1 cross B2 is root 59. Okay, students. And students, our shortest distance will be equal to here B1 cross B2. So B1 cross B2 is 3i minus j minus 7k dot a2 minus a1, which is I minus k, and this is under root 59. Shortest distance is, we can write, student, this is 3 and minus 1 and plus 7 by under root 59. So shortest distance is 7 and 3, 10 minus 1, 9 by under root 59. Okay, students, so okay, students, so here is, student, our j is 0, so this part will be 0 and it will be 10, and shortest distance is 10 by 9 units. Okay, students, so this will be our shortest distance between these two vectors. Okay, I hope you understand, students. First of all, students, we are comparing this vector equation with the standard form of line, which is r is equal to a plus lambda b, and we find out a1, which is I plus j, b1 2i minus j plus k, a2 2i plus j minus k, b2 3i minus 5j plus 2k. Okay, students, and students, we know the formula of shortest distance b1 cross b2 dot a2 minus a1 by modulus of b1 cross b2, and a2 minus a1 is equal to, students, we write a2 minus a1 and we get a2 minus 7 I minus k. Okay, and our b1 cross b2 is, we write in the determinant form I j k a1 b1 c1 a2 b2 c2, and when we expand this, student, we get b1 cross b2 is 3i minus j minus 7k, and magnitude of this, student, we write under root 3 square minus 1 whole square plus minus 7 whole square, this is root 59. So this is our magnitude of b1 plus b2, students, and our shortest distance is equal to, this is our b1 plus b2, and this is a1 minus a1, a2 minus a1, and this is our magnitude of b1 plus b2. And students, we write and we get the 10 by root 59 units. This is our shortest distance between these two vectors equation. Okay, students, I hope you understand. Now we take another question. Our next question is, students, find the coordinate of the point where the line through the point this and this crosses the plane. So, students, we have find the coordinate of point which is passing through the 2 point A, which is 3 minus 4, minus 5 and B 2 minus 3 1. Okay students, crosses the plane and our plane is 2x plus y plus z is equal to 7. Okay students, so students, we have to find that point where the passing through the line passing through these 2 points, okay, and crosses this plane. So first of all students, we find the equation of that line. So equation of line, suppose that this is our plane and a point A and B. A is 3 minus 4 minus 5 and B is 2 minus 3 1, and the equation of plane is 2x plus y plus z equal to 7, and this is the point whose coordinate is length we have to find. Okay, so we will let the equation of line passing through three minus 4 minus 5 and 2 minus 3 1. So we know the formula of students passing through equation of line passing through 2 point is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. So we put here x minus x1, which is 3, by x2 minus x1, y minus y1, y minus y1 by y2 minus y1, and z minus z1 by z2 minus z1. So students, when we solve this, we write x minus 3y minus 1, y plus 4 by 1, z plus 5 by 6. So this is the equation of line which is passing through the point A and B. Okay students, and we let that this point, this line AB intersect the plane at the point P alpha beta gamma. Let the line 1 intersect the plane at point P alpha beta gamma. Okay students, so when this line intersects the plane at this point, so this point will satisfy the equation of this line and this plane. So we write students alpha minus 3y minus 1, beta plus 4 by 1 and gamma plus 5 by 6, and we will suppose that this is equal to a constant lambda. So alpha is minus lambda plus 3 and beta is lambda minus 4 and gamma is 6 lambda minus 5. Okay student, so the coordinate of alpha beta gamma we have find out, because from this equation we can get the general values of alpha beta gamma, okay, at that line. So student, now we are seeing that this point, this alpha beta gamma also satisfy the equation of plane strengths, because this is the point which is the intersection of this line and plane. So this will satisfy the equation of plane also. So we write alpha beta gamma satisfy the equation of plane. So right students, our 2 alpha plus beta plus gamma is equal to 7. So students, alpha is minus lambda plus 3 plus beta lambda minus 4 plus gamma 6 lambda minus 5 is equal to 7. So we write minus 2 lambda plus 6. This is 7 lambda and minus 9 is equal to 7. Okay students, so this is 7 minus 2. This is 5 lambda minus 3 is equal to 7. So students, from here we write lambda is 10 by 5. So lambda is 2. Okay students, after getting lambda is 2 students, we find the coordinate of point P, which is alpha, beta, gamma. So coordinate of P is, we have to give in minus lambda plus 3, lambda minus 4 and 6 lambda minus 5. So we put minus 2 plus 3, 2 minus 4 and 6 into 2 minus 5. So we get 1 minus 2 and 7. So this 1 minus 2 comma 7 is the point of intersection of this plane and this line, which is passing through the point A, 3 minus 4 minus 5 and B, 2 minus 3 comma 1. Okay students, so this will be the required coordinate. So students, first of all, we have find out the equation of this line AB, which is x minus x1 by y minus y1 is equal to x2 minus x1, which is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. So we get the equation first from here, and now students, we let that the intersection of this line and plane is the point alpha, beta, gamma. So this will satisfy the equation of this line. So we satisfy that equation with the point alpha, beta, gamma. We get alpha is minus lambda plus 3 and beta is lambda minus 4 and gamma is 6 lambda minus 5. And students, we know that this alpha, beta, gamma also satisfy the equation of this plane. So we replace this x, y, z with the coordinate alpha, beta, gamma. So we write 2 alpha plus beta plus gamma is 7. And students, and we know the alpha, beta, gamma is this. When we put the value, we get the whole lambda is 2. After getting lambda is 2, we put the value of lambda here and we get the coordinate. Okay students, which is 1 minus 2 comma 7. I hope you understand students. Now we move to next question. Our next question is student. Our next question is, next question is students, find the equation of line passing through the point P 4, 6, 2 and point of intersection of line and plane. So students, there is plane whose equation is given and the line whose equation is given also, and we have to find the equation of this line which is passing through the point P, which is 4, 6, 2. Okay students, and equation of plane is x plus y plus z is 7. X plus y minus z is equal to 8, and the equation of line is x minus 1 by 3 x minus 1 by 3 is equal to y by 2 is equal to z plus 1 by 7. Z plus 1 by 7. Okay, students, so we have to find the equation of this line PQ. Okay, so this is the intersection point of this line and this line, and we let the coordinate A, which is alpha, beta, gamma. So students, this is the intersection of point of this line and this plane. Okay, so we have to find the equation of plane line passing through this point. So when we calculate the point A, then we can easily find the equation of this line. So for this we write the point of intersection of line and plane is alpha, beta, gamma. So it satisfies the equation of lines and plane. So we write alpha minus 1 by 3, beta by 2, and gamma plus 1 by 7. And plane is alpha plus beta minus gamma is equal to 8. So this is 1 and this is 2 square. Now we take this is lambda. So alpha is 3 lambda plus 1 and beta is 2 lambda and gamma is 7 lambda minus 1. Okay, students, so alpha, beta, gamma is this student, and you know this satisfies this equation also. So we write from equation 2, we write 3 lambda plus 1 and plus 2 lambda plus minus 7 lambda plus 1, which is equal to 8. So student, this is 2 and 3, 5 lambda minus 7 lambda. So 2 lambda plus 2, which is 8. So minus 2 lambda is 6. So lambda is minus 3. Okay, students. So lambda is minus 3 from here, and we find the coordinate of A. So coordinate A is, which is minus, this is a 9 plus 1, and this is minus 6 and minus 7 minus 3 minus 1 student. So we get the point which is minus 8 minus 6 and minus 22. So this is student's point, and we find the point, the equation of line passing through 4, 6, 2 and minus 8, minus 6, minus 22. Okay, students, so what we write, x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, and z minus z1 by z2 minus z1. Okay, friends, so when we further solve it, we get the equation y minus 6y minus 12, and this is z minus 2 by minus 24. So we write, after simplification we get x minus 4 by 1, y minus 6 by 1, z minus 2 by 2. So this will be required equation of line which is passing through the point 4, 6, 2. Okay, students, so in this way we can find out the equation of line which is passing through the intersection of this and this. So students, let's see once again. We have find the equation of this line PQ, which is the intersection point of this line and plane. Okay, so we have taken the intersection of this line and plane is alpha, beta, gamma. Okay, students, so if this is the intersection point of this line and plane, so it will satisfy the equation of line and plane also. So when we satisfy this equation, we get alpha minus 1 by 3, beta by 2 is a gamma plus 1 by 7, which is equal to lambda. Okay students, and this equation will be alpha plus beta minus gamma is equal to 8. Now we suppose that this is equal to lambda, which is a constant. So alpha is 3 lambda plus 1, beta is 2 lambda, and gamma is 7 lambda minus 1. Now students, from equation second, when we put this alpha, beta, gamma in this equation, we write this is 3 lambda, 2 lambda, and minus 7 lambda, minus 2 lambda, and this is 2 and 8. So we get from here our lambda is equal to students minus 3. Now we find the value of this coordinate of intersection point, which is minus 8, minus 6, minus 2. Now we get to point this and this. Now easily with the help of these 2 points, we can get our equation of line passing through this P8. So that will be x minus 4 by a minus 8 minus 4, y minus 6 by minus 6 minus 6, z minus 2 by minus 22 and minus 2. Okay students, and when we simplify this, we get the result. Okay students, I hope you understand. So thank you so much.